Hello and welcome to section 2.6a, rational functions and asymptotes. Today we are going to talk about rational functions and asymptotes, but if you have any questions, remember on these examples, please bring them to class so that we can talk about them. So this first example, it says find the vertical asymptotes of the following and identify the domain of the rational function, and lastly sketch the graph of the function. So if we are going to go through and find the vertical asymptotes, first thing we do is we set the denominator equal to 0. So if I set 3x squared plus 1 equal to 0 and solve it, I'm going to get 3x equals negative 1, divide 3x squared equals negative 1, divide by 3, x squared equals negative 1/3. And so then basically, because I can't take the square root of a negative number without getting imaginary numbers, there are no vertical asymptotes. Well, when we look at this graph, if I need to sketch a graph, I need some more information. And so what I'm going to look for is that the degree of the top is less than the degree of the bottom. So there's a horizontal asymptote at y equals 0. So just a little bit more information when we're looking at this. And so if I'm going to sketch a graph, and I'm just going to use my graphing calculator, I've already plugged in the equation. And when I hit graph, let's see if that helps. You can't really see what's going on there. Nope, that's not good enough. Let's change our y value. Let's change our window to our y values to -2 and +2. Let's see what that does for our graph. And there you go. That's a little bit better sketch of the graph. And so that's really what we're trying to do. The only other thing we could do to help us out is find out where it crosses the x-axis, which is 0. And so that would be x and y-axis by trying to find where it crosses. If I put 0 in for y and solved, I'd find out, or put 0 in for x, I'd find out that 0, 0 is the place it's crossing. So the best way to get a sketch of this graph is to graph it on your calculator. So then on the next one, we know that we are going to find our vertical asymptote again. So we'll try to find a vertical asymptote by setting x squared minus 1 equal to 0. And if I solve, then I get x squared equals 1. And so x is equal to plus or minus 1. So there's two vertical asymptotes in this graph. Also, I noticed that the degree is the same top and bottom. So for my horizontal asymptote, I set, basically it's the leading coefficients, which is 2 over 1. So y is equal to 2. So I've got a horizontal asymptote at y equals 2. And so I don't believe I'm going to have any x or y intercepts if I was to solve this. So I'm going to quickly sketch a graph of this, which I've already set up on my calculator. And so to sketch the graph of this, see if you can see it. Oops, I'm going to change my window just a bit, make this -5 and +5. And by doing that, I get a little bit better graph. You still can't see it though. So let's change my y to -10 and +10. And so we get a graph that looks something like that, and that's really what we're looking for. And on this graph, you could see that I do have a horizontal asymptote here at 2. If I was to kind of draw a line, oops, if I could even come close to drawing a straight line, I would end up with a horizontal line of where my asymptote is. So we'll try this. We'll be a little bit better. We'll use a straight line. And so there's a horizontal asymptote there. You can see the two vertical asymptotes that are drawn on my that are already drawn in my graph, and so this is what the graph would look like. And in order to sketch a graph of this, we would have to pick values like ordered pairs inside the vertical asymptotes. Like I'd have to pick knowing that I have a horizontal asymptote of y equals 2, if I didn't have a graphing calculator, I'd have to pick like x is -1 or -2 and y is +3 or something like that, and plug it into this graph to see if I was above or below this asymptote. And we've done that before. It's just going to be something that we're going to work on as we go about this to get a little more sketching of our graph. Alright, so then the next one, it says find the vertical asymptote and the domain of the following function. So we're going to go through and do that. So if we set the denominator equal to 0, we can help work on finding our vertical asymptotes. And so I set this equal to 0, and just solving, it's something like this, and then I can take the cube root. So it looks like the cube root of 5/4 is my vertical asymptote in this case. And so all numbers except that will work. That's going to basically be our vertical asymptote. And then we can find a horizontal asymptote. So for our domain of this, basically we're saying that these guys will not work. It's the only one that doesn't work. And so we could say all reals except this number, and this is approximately like 1.08 if I was going to look at it. And so we could say that our domain is negative infinity to 1.08, and then positive infinity, or 1.08 to positive infinity. That would be my domain. I could come up with a sketch of the graph, and just to kind of see what it looks like, we'll make a quick little sketch of it. Believe. Let's see if this will do it for us. And so you should be able to see at approximately, let's see, I'm going to reset my window. You can see at approximately that 1.08 my graph is going to there, and again in this case, since the degrees are the same, we should have a horizontal asymptote at like negative 3/4, and so you can kind of see that on the graph also. Alright, so then moving along here, if we're asked to find the x and y intercepts of the following, and this is just to help us get sketches of graphs. And so if I'm looking for x-intercepts, I'm going to plug 0 in for y, because that's where I'm crossing the x-axis. So 0 is going to equal x squared minus 5x plus 6 all over this thing on the bottom. And doing some algebraic manipulation, I'm going to multiply by x squared plus 6 on both sides. That'll get rid of my division. And so the good news is those guys go away, so this is still 0 equals. And then in order to get my x-intercepts, I'm going to have to factor this. And when I factor it, remember that I am using positive 6, negative 5, and I need to come up with what factors give me that, which would be negative 3, negative 2, and that's how I jump to this. And so then my x-intercepts are x equals 3 and x equals 2. So I'm going to write them as ordered pairs up here, 3, 0, and 2, 0. If I'm looking for my y-intercepts, then I need to figure out when my x's are 0, what is my y value? And so f of x will equal 0 squared minus 5 times 0 plus 6 all over 0 squared plus 4. And a quick little simplification gives me 6/4, which is really 3/2. And so then my y-intercept is 0 and 3/2. And so then that would help me find some of my graph and things like that. I notice that I have a horizontal asymptote when both of the, because my exponents are the same. So I have a horizontal asymptote at 1. I have a horizontal asymptote at y equals 1. So again, I could find some good information from this by just getting the x and y intercepts and the horizontal asymptotes. I also know that I have no vertical asymptote. Vertical asymptote is none, because if I set the bottom x squared plus 4 equal to 0, I'm not going to get a real number. So there I could, with all that information, I could pretty much get a good graph of what I'm looking for. So then in this guy, same thing, they're asking for x and y intercepts. So I'm going to solve it. I'm going to put 0 in for y again to find my x-intercepts, and to do a little bit of algebra here. So I'm going to subtract 5, negative 5 equals 3 over x squared plus 1. Multiply the top and bottom by x squared, multiply both sides by x squared plus 1. And so these guys cancel out, so I'm left with negative 5x squared minus 5 equals 3. And then if I subtract 3 across the equal sign, I get negative 5x squared minus, looks like minus 8 equals 0. And then if I start solving, Well, add 8 across the equal sign, I get negative 5x squared equals 8, and then dividing by negative 5, x squared is going to be a negative 8 fifths. Well, now if I try to take the square root of this, I'm going to get some imaginary solutions, which means that this graph is not crossing the x-axis. So there's no x-intercepts. There still could be y-intercepts, and that's just as solving for y when I put 0 in for my x's. And you can see that if for my y-intercept, this should end up being 8, which means that I have 0 for x, 8 for y. And so with no x-intercepts, in order to get, this has no horizontal asymptote. It has, it doesn't have any vertical asymptotes because, again, if I set this equal, the bottom equal to 0, so this graph is just going to be, I don't know, kind of a squiggly line or something. And so anyway, this concludes our examples for 2.6a, rational functions asymptotes. Remember, if you have any questions on any of these, please come to class and ask your questions. Thank you.